Today we're introducing Chem Activity 23A, carbonyl reactivity. And carbonyls in general do addition reactions with a nucleophile and a hydrogen adding across the carbon-oxygen bond. Now to discern this reactivity, we need to think about the polarization of a CO pi bond. The oxygen, in fact, has an excess minus charge, and the carbon has an excess positive charge. Therefore, a nucleophile is attracted to the delta plus charged carbon, and a hydrogen will be attracted to the oxygen, like so, to give the outcome shown. The vast majority of the carbonyl reactions we will see in upcoming chapters involved some nucleophile interacting with a carbonyl and either before or after the proton being added on the other end. So then the question becomes, which happens first? Does the nucleophile add first or does the proton add first? And as with many other reactions, the answer is it depends. For our strong base nucleophiles, set negative charge on oxygen, nitrogen, or carbon, we find that nucleophiles attack the carbonyls first before any protonation takes place, with the arrows shown. This creates a relatively strong base also after our initial addition. In this sense, we do not create a base that is any weaker than the strong bases we start out with. After our initial addition of our nucleophile, we normally wait around for a second synthetic step in which some proton source, often H3O, is added in order to do our protonation. On the other hand, if we start with a nucleophile that is a weaker base, such as our neutral alcohol or amine, we wouldn't have enough nucleophilicity to do a forward reaction. However, if we protonate first we create a very active electrophile in the carbon atom, and our neutral nucleophiles will have no problems adding. Chem Activity 23A introduces the idea of carbonyl reactivity through nucleophilic addition in both strong bases, which add to the carbonyl carbon before you protonate, and weaker bases, which add to the carbonyl carbon after protonation. We also address things like Le Chatelier's principle and the fact that when you have equilibria reactions, that you can push or pull on one side or the other to create the reaction going in the direction you want. If you add a nucleophile and a proton to a carbonyl and it's a reversible process, you can force the reaction to go back to the carbonyl or forward to the addition product depending on your reaction conditions.